Hey everyone, this is question number 36 from chapter 13. So this problem is about a test tube that is stopped, and the test tube stopper will pop off if 10 newtons of force is applied from the inside. Okay, and it asks, to what temperature would you have to heat the trapped air in the test tube in order to pop off the stopper, okay? So we're given some initial conditions, and we can start this problem. We need to think about the relationship between pressure and force. So pressure is a force time per area, okay? So we can solve for force by multiplying pressure by area. Okay, so when the stopper is in place and not moving at all, the pressure inside and outside the stopper, inside the test tube and outside the test tube, is the same. We're told that it's 1 atmosphere, okay? So 1 in minus 1 out is going to be 0. Okay, so we can say that F net equals P in minus P out times the area of the stopper. Okay, so now we can find the relationship between the pressure inside the tube, what it needs to be, and where it started, okay? So we have our ideal gas equation, PV equals nRT. The amount is staying the same, so we can set up this relationship, P1 V1 over T1 equals P2 V2 over T2. Okay, so 1 is going to be inside the tube, and 2 is going to be where it started. So I'm going to rewrite this. P in V tube over the temperature inside equals P naught V tube over T naught. Okay, so now we can solve this equation for P in. P in equals P naught times T in over T naught. Okay, notice volume is in this equation because volume of the tube does not change. It's on either side, so it can be taken out of the equation, okay? All right, so from here, we can plug this relationship back into our F net equation up here, okay? So we're going to plug this into what I just underlined. Okay, so F net now equals P naught T in over T naught minus P naught times A. Okay, so again, that's just plugging this relationship between P in, P naught into P in minus P out, okay? Out is our original pressure. Okay, so we can solve that equation. We can actually take P naught out of this equation to simplify it a little bit. So we get equals P naught T in over T naught minus 1 times area. Okay, so now we can solve that equation for temperature on the inside. Okay, so now T in equals F net over P naught A plus 1 times T naught. And we can plug all of our numbers into this. We have all these values. Okay, so T in equals 10 newtons, which we're told is the net force that's required to pop the top off. We're going to convert atmospheres to pascals. So 1.013 times 10 to the 5th pascals. And this is so we can relate force to area. That's just one atmosphere, which is P naught. And then the area of the stopper, pi, we're given the radius, 0.0075 meters. And that's squared. And then all that plus 1 times T naught, which we're given, and we need to convert to Kelvin 273 plus 18. Okay. All right, so now plug all that into your calculator and you get Tn equals 454 K, which we can round, or not round, minus, we can convert to degrees Celsius, minus 273, and you get 181 degrees C.